Hello, good morning students. लास्ट लेक्चर में हमने डिस्कस किया था the minimum number of teeth required on the pinion in order to avoid interference. Today's topic is the minimum number of teeth required on wheel in order to avoid interference. Okay, consider the gears. This is the wheel and this is the pinion. The center of the pinion is Q and the common tangent points touches at the point N, and the center of the wheel is O and common tangent touches the base circle at the point M. This is the pitch point P and the pressure angle is phi. Let capital T is equal to the number of teeth on wheel, number of teeth on wheel. Small t is equal to the number of teeth on pinion Small m is module of t. Small d is equal to the pitch circle diameter of pinion. So G will be is equal to module into number of teeth on pinion. If small r is equal to the pitch circle radius of pinion, then small r will be is equal to capital D small d by 2 or module into number of teeth divided by 2. Let capital D is equal to the pitch circle diameter of wheel. It will be equal to the module into number of teeth on wheel divided by equals to diameter of pitch circle of wheel. If capital R is the pitch circle diameter of pinion equals to small m into capital D by 2. Okay. Capital G is equal to the gear ratio, and it will be equal to the capital D by small r, capital R upon small r, or number of teeth on wheel divided by number of teeth on pinion. Phi is the pressure angle. Now, from triangle OPN, okay, from triangle OPN, ON square will be equal to the OP square plus PN square minus 2 into OP into PN into cos OPN. ON square will be equal to the OP square. OP is the pitch circle radius of the wheel plus PN. PN will be equal to the small r sine phi whole square minus 2 into capital R into small r sine phi, and OPN will be equal to the 90 plus phi. From here ON square will be equal to the r square plus r square sine square phi minus 2 into r sine phi bracket cos 90 plus phi is equal to minus sine phi. Okay. Now ON square will be equal to the r square plus r square sine square phi plus 2r into r sine square phi. Capital R square is taken from the equation. This is 1 plus r square upon capital R square sine square phi plus 2 small r upon capital R sine square phi. ON square will be equal to the r square 1 plus small r upon capital R has been common from the equation. Small r upon capital R plus 2 sine square phi or ON will be equal to the R under root 1 plus small r upon capital R small r upon capital R plus 2 sine square phi. Okay. We know that addendum of the wheel of wheel will be equal to the ON minus OP. OP is the fixed circle radius of the wheel. Or putting the value of ON from the above equation, capital R under root 1 plus small r upon capital R small r plus upon capital R plus 2 sine square phi minus r or small m into capital R has been common from the equation. We will get under root 1 plus small r upon capital R small r upon capital R plus 2 sine square phi minus 1 or small m module into number of teeth on wheel divided by 2 within bracket 1 plus small r upon capital R bracket small r plus upon capital R plus 2 sine square phi minus 1. The addendum of wheel small m module into number of teeth on wheel divided by 2 under root 1 plus 1 by g 1 by g plus 2 sine square phi minus 1. Let AW into M will be equal to the addendum of wheel to avoid interference where AW will be equal to the fraction by which the standard addendum of one module or wheel should be multiplied in order to avoid interference. Okay, so addendum of wheel will be equal to AW into M. From the above equation, AW into M will be equal to this module into number of teeth on wheel divided by 2 under root 1 plus small r upon capital R small r plus capital R plus 2 sine square phi minus 1, or AW will be equal to the capital T by 2 under root 1 plus small r upon capital R small r upon capital R plus 2 sine square phi minus 1. Our total number of teeth T will be equal to the 2 into AW divided by within bracket 1 plus small r upon capital R small r upon capital R plus 2 sine square phi minus 1, or capital T will be equal to the 2 into fraction of addendum 1 plus 1 by g plus 2 sine square phi minus 1. This is the equation for minimum number of teeth on wheel to avoid interference. Here, if gear ratio is equal to 1, in that case capital T will be equal to the 2 into AW 1 plus 1 plus 2 sine square phi minus 1 equal to the 2 into AW 1 plus 3 sine square phi minus 1. Okay. Now solve a problem on this topic. A pair of spur gears with involute teeth is to to give a gear ratio of 4:1. The arc of approach is not to be less than the circular pitch and the smaller wheel is the driver. The angle of pressure is 14.5 degrees. First, what is the least number of teeth that can be used on each wheel? And second, what is the addendum of the wheel in terms of circular pitch? Okay. Now, first of all, write what data has been given in the numerical. The gear ratio G is given 4:1, or capital T by small t is equal to capital R upon small r is equal to 4. Pressure angle has been given. Pressure angle is phi. Arc of approach is not less than the circular pitch. According to the numerical, arc of approach is not less than the circular pitch. So length of approach will be equal to the circular pitch. PC. First, least number of teeth on each wheel. Okay, let us find the maximum length of arc of approach and the value of circular pitch. So maximum length of arc of approach will be is equal to the maximum length of path of approach divided by cos phi, but maximum length of path of approach is equal to the r sin phi. So maximum length of arc of approach will be is equal to small r sin phi upon cos phi, small r tan phi. circular pitch PC will be equal to the pi into module, or circular pitch will be equal to the pi into 2r by t. According to the question, r times phi will be equal to the pi 2r by t. Maximum length of arc approach is equal to the circular pitch. So from here, small t is equal to the pi into 2 divided by 10 phi. Phi is 14.5, so 2 pi upon 10 14.5 degree is equal to the 24.3, or number of teeth on pinion will be equal to the 25. So total number of teeth on wheel will be equal to the gear ratio multiplied by number of teeth on pinion, which is 4 into 25. It means number of teeth on the wheel will be 100. Okay. So the least number of teeth on pinion will be 25, and number of teeth on the wheel will be 100. Now, second part, addendum of wheel in terms of circular pitch. Addendum of wheel equal to the small m into capital T by 2 bracket 1 plus 1 by g bracket 1 by g plus 2 sin square phi minus 1. Number of teeth on wheel is 100. Gear ratio is given 4. And pressure angle is given 14.5. So addendum is 50 m into 0.8735, or 0.2835 into PC by pi, or 0.27 8 into circular pitch. Okay. Now come to the next numerical. A pair 20-degree full depth in volute spur gear having 30 and 50 teeth respectively of module 4 mm arc in mesh. The smaller gear rotates at 100 rpm. Determine first sliding velocity at engagement and at disengagement, and B contact ratio. Now, given pressure angle phi is equal to 20 degree, number of teeth on pinion is 30, number of teeth on wheel is 50. So the gear ratio is equal to the capital T upon small t, 50 by 30, 5 by 3. Module M is equal to the 4 mm. Speed N1 is given 1000 rpm of a smaller gear. So angular velocity of a smaller gear omega 1 is equal to the 2 pi n1 by 60 or 2 pi into 1000 by 60 is equal to 104.67 radian per second. Now part A, sliding velocities and engagement and disengagement. Okay. For determining the sliding velocity, first of all calculate the addendum of wheel and pinion. Addendum of wheel will be equal to the 1 plus 1 by g, 1 by g plus 2 sine square phi minus 1. Module is 4. Number of teeth on wheel is 50. Under root. Gear ratio is 5 by 3. And pressure angle is 20 degree. So it will be equal to the 9 mm. Okay. Addendum of wheel will be equal to the 9 mm. Now addendum of pinion will be equal to module into number of teeth divided by 2 within bracket 1 plus g plus 2 sine square phi minus 1. Module is 4, number of teeth on pinion is 30. Gear ratio is 5 by 3. Pressure angle is 20 degree. Calculating the module of pinion, addendum of pinion. Addendum of pinion is 18.54 mm. Okay. Pitch circle radius of wheel will be equal to the R. R will be equal to the small m into capital T by 2. Small m is 4, capital T is 50 divided by 2. It will be equal to the 100 mm. So radius of addendum circle of wheel circle of wheel will be equal to the RA. RA will be equal to the pitch circle radius of the wheel plus addendum of wheel. RA will be equal to the 100 plus 9 equals to the 109 mm. Now, pitch circle radius of pinion small r, small r is equal to the small m into t by 2. Module is 4, number of teeth on pinion is 30. So the radius of pitch circle of pinion will be 60 mm. Now the radius of addendum of pinion, addendum circle of pinion is small ra. Small r will be equal to the small r plus addendum of pinion. Addendum of pinion will be radius of addendum of pinion is 15.54 mm. So the total radius of addendum circle of pinion will be 78.54 mm. Okay. Length of path of approach approach will be equal to the under root RA square minus R square cos square phi minus R sin phi radius of addendum circle of the wheel is 109. The circle radius of wheel is 100. Pressure angle is 20 minus 100 into sin 20. It will be equal to the 21.03 mm. This is the length of path of approach. Now the length of path of recess. It will be equal to the under root RA square minus R square cos square phi minus R sin phi under root. Radius of addendum circle of the pinion is 78.54 and pitch circle radius is 60. Pressure angle is 20 degree. It will be equal to the 34.2 mm. This is the path of recess. Angular velocity of speed of the wheel is omega 2 and angular velocity of the speed of the pinion is small omega 1. Then it will be equal to the small t upon capital T. Then omega 2 will be equal to the 30 upon 50 into omega 1, which is 104.67. So angular velocity of the wheel will be 62.8 radian per second. Okay. So sliding velocity of engagement will be omega 1 plus omega 2 into length of path of approach. It will be equal to 104.67 plus 62.8 into 21.03. It will be 3.522 meter per second. And sliding velocity of disengagement will be omega 1 plus omega 2 into length of path of races. This is 104.67 plus 62.8 into 34.2. It will be equal to 5.727 meter per second. Okay. Now the contact ratio. Contact ratio will be is equal to length of arc of contact divided by circular pitch. So it will be 21.03 plus 34.2 divided by cos 20 into 1 by pi into module, which is 4. So it will be equal to the 4.67. The contact ratio will be 5. Okay.